Now let's discuss laminate object manufacturing. What is laminate object manufacturing? Laminate object manufacturing, or LOM, is a 3D printing technology that works by cutting and bonding layers out of a sheet of laminated material to each other onto a build plate. As you can see by the illustration on the right, you have a feed roll which feeds a sheet of laminated material. This could either be paper or wood or metal or plastic or many others. Feeds it off of a sheet from a feed roll onto a waste roll, and the sheet material is fed over a build plate over the workspace where a laser traces the outline of each layer, and in doing so cuts the layer out of the sheet, and subsequently a heated roller passes over the sheet which bonds it to the layer beneath it. This is repeated for each layer, and in between layers the build platform which holds the test piece is lowered for each layer. Due to the limitation of the build material sheets, this is mostly used for larger builds, as it is not suitable for fine details due to the limitations of the resolution that it can produce. A lot of processing to cut the finished piece out of the surrounding build material might be required, adding to the cost and time of producing finished products. Now that we have touched upon what LOM is, let's cover some of the advantages and disadvantages of this technology. Some of the advantages of layer object manufacturing are it's very fast for making large-scale parts, as may be used in architectural models and architectural 3D diagrams. Because of the price of the materials, which is relatively cheap, you can produce large-scale parts for a relatively low cost. In addition, there might not be a need for support structures in the design, because each layer is supported by the sheet layer underneath. This is mostly due to each layer in layer object manufacturing. After the heated roller passes over it, it completely bonds to the layer underneath. So you always get a square rectangle in the shape of the workspace, out of which an area which represents the cross-sectional area of each layer to be printed is cut out. Now that we have covered some of the advantages, let's move on to some of the disadvantages of layer object manufacturing. As we have touched upon, the resolutions of parts produced can be relatively low. This means that layer object manufacturing is relatively only suited for larger scale parts. Tiny miniatures or accurate features cannot be effectively reproduced using this technology. Due to the bad resolution of parts, you also end up having a relatively bad surface finish, and post-processing might be needed to smooth off the surface. Tiny, small objects or prints cannot be produced using this technology due to the limitations of the sheet dimensions or the laminate dimensions, due to the workspace dimensions, and also due to the way that the sheets are bonded to each other. Also considering that your final test piece will reside in a cube of material because of the workspace in which the sheets are cut and bonded, it might be difficult to remove your final piece out of this mold of waste material. Also considering this, you have to factor into the account the amount of waste produced using this process. Obviously, if you are using paper or wood laminate, obviously this is biodegradable and doesn't have such an ecological impact. However, if you use plastic sheets or plastic laminates, then this could have a larger environmental impact and is not as desirable. Also, considering all of these disadvantages, you can easily infer that layer object manufacturing can have a limited applicability to what can be produced with this technology. So let's cover some of the applications of layer object manufacturing. In the industrial sector, you can produce architectural models such as of buildings or of landscapes to be used for presentations. Traditionally, these models are created through an art and craft method using a very manual approach. So, an architect, when building the model, would generally have to craft this himself by hand. However, using layer object manufacturing, the architect could be able, if he has a 3D model of what he'd like to present, he could send this 3D model off to be 3D printed using layer object manufacturing, cutting down on production time and man hours and freeing up the architect himself to work on other projects in the meantime while this is being produced. On the topic of architectural models, also topographical maps can be produced, which represent the different landscapes and is used for geographical representations. So if you'd like to model the landscape of hills, cliffs, and mountains of a particular area or region for geological purposes or architectural purposes when landscaping or site overviews, you can create such topographical maps using layer object manufacturing. Also, considering the large-scale application of layer object manufacturing, you can produce large-scale parts for such purposes. So if you want a one-to-one scale of large physical components, layer object manufacturing can be utilized to produce such components at a relatively fast speed and for relatively low costs. So in this aspect, it could be good from a prototyping aspect as opposed to selective laser melting, which would take a relatively long time, or fuse deposition modeling and stereolithography, which are not that well suited for such larger scale applications. Also, considering this, the material costs in layer object manufacturing are also relatively low when compared as to selective laser melting and sintering, which uses metal, which is much more expensive, and infused deposition modeling and stereolithography, where the material costs can quickly add up for larger parts and components. In summary, the most common 3D printing technologies are selective laser melting and selective laser sintering, which uses a laser to melt metal powder in a layer-by-layer approach. Fused deposition modeling, which uses thermoplastic filament, which is extruded in lines in a pattern in the layer-by-layer approach. Stereolithography, which uses a UV curing or photosensitive resin in a resin bath or pool, where a UV laser is used to harden each layer onto a build plate subsequently in a layer-by-layer approach. And last but not least, laminate object manufacturing, which uses the cutting and thermal gluing of laminated sheets in the layer by layer approach. Thank you and see you next week.